think you know everything about our planet. Today we're diving into some incredible facts about our home planet, Earth. You know, that pale blue dot we call home, the third rock from the sun. It's a planet teeming with life, with a molten core, and a history that spans billions of years. We often take Earth for granted, but trust me, there's a lot more going on than meets the eye. From the highest mountains to the deepest ocean trenches, Earth is full of surprises. You might think you know your planet, but we're about to explore some mind-blowing facts that'll change your perspective. Get ready to have your mind boggled, because we're about to embark on a cosmic journey to uncover the hidden wonders of our own backyard. So buckle up, space cadets, as we delve deep into the fascinating and sometimes bizarre realities of our home planet. We're going to explore everything from leaking atmospheres to invisible superhighways in the sky. You won't want to miss this cosmic ride. You might think of Earth's atmosphere as this constant protective blanket, shielding us from the harsh realities of space. And you wouldn't be wrong for the most part. But did you know that our atmosphere is actually leaking? It's true. Every single day, about 90 tons of atmospheric gas escape Earth's gravitational pull and drift off into the vast expanse of space. Now, before you panic, imagine a giant beach ball. That's Earth. And imagine a single grain of sand slowly drifting away. That's roughly the scale we're talking about here. It's a tiny, tiny amount compared to the overall mass of our atmosphere. It's like trying to empty an Olympic-sized swimming pool one drop at a time. We're talking about a process so slow that it would take billions of years for any significant change to occur. To put that in perspective, that's longer than the entire history of life on Earth. So, rest assured, you can breathe easy knowing that we're not about to run out of air anytime soon. We all know that Earth spins on its axis, giving us our days and nights. It's a fundamental part of our planet's rhythm, as predictable as the sunrise. But what if I told you that Earth's rotation is actually slowing down? It's true. This cosmic dance we share with our moon isn't without its consequences. You see, the moon's gravity exerts a slight tug on Earth, creating tides in our oceans. This tidal force acts as a sort of brake on Earth's rotation, slowing it down ever so slightly over time. Now don't worry, we're not talking about any sudden changes here. We're talking about milliseconds per century. It's a gradual process, like watching a spinning top slowly lose momentum. But over millions and billions of years, these milliseconds add up. In fact, if we were to travel back in time to the age of the dinosaurs, a day on Earth would have been about 23 hours long instead of our current 24. You might think of the sky as this empty, limitless expanse. And sure, on a clear day, it might seem that way. But high above our heads, there's a whole lot of traffic going on. We're talking about jet streams, these roaring rivers of wind, invisible to the naked eye, but with the power to shape weather patterns across entire continents. These jet streams are like giant conveyor belts, transporting weather systems from west to east at incredible speeds, sometimes exceeding 200 miles per hour. That's faster than most commercial airliners. They form at the boundaries of hot and cold air masses, where the temperature differences create these powerful pressure gradients that drive the winds. Think about it. These jet streams are like nature's own roller coaster. Pilots have known about them for decades, and they actually use them to their advantage. By riding the jet stream, flights going eastbound can significantly reduce travel time and save fuel. Talk about a free ride. But they can be a bit bumpy, so buckle up. So next time you check the weather forecast and see a big storm system moving across the country, remember those invisible superhighways in the sky, the jet streams, silently orchestrating the atmospheric show from high above. We often picture Earth as a perfectly smooth sphere, spinning gracefully in the void of space. But the reality, my friends, is far more interesting. Earth is a bit lumpy, kind of like a potato, and this imperfection has some fascinating consequences for gravity. You see, gravity is not uniform across the planet. It varies subtly depending on where you are. Now you might think, Neil, are you saying that if I jump higher at the equator? Well, not exactly. The differences in gravity are incredibly small, barely noticeable to us humans going about our daily lives. But sensitive instruments can detect these variations, and they tell a fascinating story about our planet's composition and structure. The Earth's uneven surface, with its towering mountains and deep ocean trenches, contributes to these gravitational anomalies. But even more significantly, the Earth's interior isn't uniform either. The density of rocks and the distribution of mass vary throughout the Earth's crust and mantle, creating these gravitational hills and valleys. So, while we may not feel the difference in gravity when we travel from one place to another, these subtle variations provide valuable insights for geophysicists studying the Earth's interior, its hidden structures, and its dynamic processes. Diamonds, those captivating gemstones, symbols of luxury and brilliance, are often associated with deep underground mines and intense pressure. But what if I told you that diamonds could rain down from the sky? Now, before you start imagining a shower of sparkling gems, let me explain. We're not talking about large, flawless diamonds here. Scientists believe that on planets like Neptune and Uranus, where the conditions are extreme, with incredibly high pressures and temperatures deep within their atmospheres, carbon atoms can bond together to form tiny diamonds, just nanometers in size. These tiny diamonds then precipitate down through the atmosphere like rain. Now, you might be wondering, could this happen on Earth? Well, while the conditions in Earth's atmosphere are not as extreme as those on gas giants, some scientists theorize that tiny diamonds could form within powerful thunderstorms. The intense pressure and heat generated within these storms, combined with the presence of carbon from sources like lightning or cosmic dust, could potentially create the conditions necessary for diamond formation, albeit on a much smaller scale than on Neptune or Uranus. Okay folks, buckle up because we're going back in time, way back, to a period called Snowball Earth. Imagine this, our planet, from the North Pole to the South Pole, encased in a sheet of ice. It's not just a little ice age, mind you. We're talking glaciers stretching across the equator, a completely frozen wasteland. Now, you might be wondering, how do we know this actually happened? Well, geologists have found evidence of glacial deposits in rocks that formed billions of years ago, in areas that would have been located near the equator. These deposits are like fingerprints left behind by ancient glaciers, telling a chilling tale of a frozen Earth. It's hard to imagine life surviving such extreme conditions, and indeed, many life forms probably didn't make it. But, and this is where it gets really interesting, some forms of life likely clung on, perhaps in pockets of water beneath the ice or around volcanic hotspots. This period of intense cold and hardship may have even spurred the evolution of new life forms, ultimately shaping the diversity of life we see on Earth today. Talk about resilience. This frozen chapter in Earth's history reminds us that our planet is a dynamic, ever-changing system, capable of conditions far more extreme than we experience today. It also highlights the incredible adaptability of life itself. Let's take a journey, shall we? Not to a galaxy far, far away, but deep beneath our feet to the center of the Earth. Forget Jules Verne's classic, "Down here, it's not a lost world, but a molten metal core, hotter than the surface of the sun." This scorching iron core is more than just a curiosity, my friends. It's the engine that drives Earth's magnetic field. You see, the constant churning and swirling of this liquid metal creates electric currents, and these currents, in turn, generate a magnetic field that extends thousands of kilometers into space, forming what we call the magnetosphere. Now, you might be wondering, why should we care about a magnetic field we can't even see? Well, it's more than just a cosmic force field. It's our planet's invisible shield. The magnetosphere acts like a giant force field, deflecting most of the sun's harmful radiation, those energetic particles that would otherwise bombard our planet, stripping away our atmosphere and making life on Earth impossible. So, the next time you use a compass, remember that tiny needle isn't just pointing north. It's aligning itself with the invisible force generated by the heart of our planet, a force that makes life on Earth possible. We've all heard of the 7 seas, those vast expanses of water that cover most of our planet's surface. But what if I told you there's another ocean, hidden deep beneath our feet, locked away within the Earth itself? This isn't science fiction, my friends. Scientists have discovered evidence of a massive reservoir of water, not in underground lakes or rivers, but trapped within the minerals deep within Earth's mantle, a region that lies between the Earth's crust and its core. We're talking about a region hundreds of kilometers below the surface, where temperatures and pressures are extreme. Now, you might be picturing vast underground seas, but that's not quite accurate. The water is not in liquid form, at least not in the way we typically think of it. Instead, it's chemically bound to the minerals in the mantle, forming what are known as hydrous minerals. These minerals can hold water within their crystal structure, effectively trapping it within the rock itself. This discovery has profound implications for our understanding of Earth's water cycle and the formation of our planet. It suggests that Earth's water may not have originated solely from comets and asteroids bombarding the early Earth, as some theories propose. Instead, a significant portion of Earth's water may have been present within the planet itself all along, slowly released from the mantle over billions of years. So, you think you know cold, huh? You've probably heard that Antarctica is the coldest place on Earth. And you wouldn't be wrong. It is pretty darn chilly down there. The coldest natural temperature ever recorded on our planet was a bone-chilling -128.6 degrees Fahrenheit. That's colder than your freezer after you accidentally left the door open all night. Now, that's cold enough to make even a penguin shiver. But here's the thing about temperature. It's all about the movement of molecules. The faster they move, the hotter something is. The slower they move, the colder it gets. And believe it or not, there are places in our atmosphere where those molecules are moving even slower than they are in Antarctica. You see, while Antarctica might hold the record for the coldest spot on Earth's surface, it's not the ultimate champion of coldness. It's like saying the tallest mountain on Earth is the tallest thing there is, but we know there are satellites orbiting much higher. When we think of mountains, we envision towering peaks piercing the clouds, their slopes covered in forests and snow. We think of the Himalayas, the Andes, the Rockies, those colossal wrinkles on Earth's surface that command our awe and inspire adventurers. And these are undeniably impressive geological formations. The Himalayas, for example, boast Mount Everest, the highest point on Earth above sea level. The Andes stretch for thousands of miles, a spine of rock and ice running down the western edge of South America. These mountain ranges are products of immense tectonic forces, continents colliding over millions of years. But what if I told you that all these mountain ranges, as impressive as they are dwarfed by another, a mountain range so vast, so extensive, that it would put all others to shame? And here's the kicker. It lies hidden beneath the surface of our oceans. Forget Everest. Forget the Himalayas. Forget everything you thought you knew about mountain ranges. The real champion, the true heavyweight of the mountain world, is the mid-ocean ridge. This underwater mountain range is a behemoth, stretching for an astonishing 40,390 miles. That's longer than the circumference of the Earth. The mid-ocean ridge is not a single continuous mountain range, but rather a network of ridges that snake around the globe like seams on a baseball. It's a place where the Earth's tectonic plates are pulling apart, creating new crust as molten rock rises up from the mantle. Imagine standing on the ocean floor, the crushing pressure of the water above you. And before you, rising up from the abyss, is a towering wall of rock, a testament to the immense forces at work deep within our planet. That's the mid-ocean ridge. It's a place of constant geological activity, where new Earth is being born. So the next time you gaze upon a majestic mountain range, remember that beneath the waves, hidden from our view, lies a mountain range so vast, so extensive, that it makes even the mightiest peaks on land seem like mere foothills. It's a reminder that our planet holds many secrets, waiting to be discovered. The Earth's core is a blazing inferno of molten metal, a fiery heart that powers our planet's magnetic field and drives the movement of tectonic plates. This intense heat, reaching temperatures as high as the surface of the sun, is a testament to the dynamic and ever-changing nature of our world. Join us as we delve into the depths of the Earth, exploring the mysteries and marvels of its inner workings. Feel the passion and power of our planet's core, a force that shapes the very fabric of our existence. From leaking atmospheres to underwater mountain ranges, Earth is chock full of surprises. We've journeyed from the coldest corners of our atmosphere to the depths of our oceans, uncovering the hidden wonders of our planet. Remember, the universe is full of mysteries, and Earth is just our starting point. Thanks for watching. If you enjoyed learning these amazing facts about Earth, don't forget to like, subscribe, and hit the bell icon for more fascinating content. See you next time!